Good afternoon. Thank you. I should just say that I'm the type that we have to have a conversation with each other. So as I go through my slides, there are some points where I expect you to speak back with me or to me. So keep that in mind. And I know it's hard, but remember, it's harder for us up here as we're talking, so I think you can help us make it easier. So as Caroline said, and we should give her a great round of applause because she's an accounting major pronouncing all these biochemical words. So let's give her an applause, please. So you have my slide? All right, so and Caroline, when she first walked out, communicated with you to tell you how this would play out, at least to inform you what TEDx talks are about. And I really want you to think about the importance of communication, but I want you to go a step further. What I really want you to think about is how our communication in society have evolved, let's say the past 200 years. Really, we don't have to go back that far. But as you watch my undergraduate research students capture what has happened to our communication over the years, I really want you to think about your families and just now technology and what it does when it's great and also what it does when it's not great, like Caroline had to just improvise. We need to really think about that. So take a moment to watch my undergraduates as they capture the history of our communication in society.
Hey Mom, how are you? It's good to hear from you. Yeah, I know, it's been a minute. School's good, just studying. How's Dad doing? Okay, that's good.
Hey, how are you?
Hi Patrick, what's up?
Nothing much.
Did you get the blocks to work?
No, I don't know what's going on.
I don't know what's going on either.
Yeah, I'll call Dom and see if he can help.
Okay.
Dom, can you help with the block?
Western blocks? Sorry, I haven't done those in a while. I totally forgot.
Okay, well, I'll get Dr. Hinton and see what we can do. Okay, bye.
Hello? Sí, ¿todo bien? Yeah, I'm going to the store to get some chicken right now. All right. Yeah, sounds good. All right, I'll see you in a minute.
So I found it interesting how we started out not using voice at all, the telegram, till we're ending still not using voice, but a different type of technology of how we're communicating with each other. And how many of you recognized the first cell phone? Did you see how big it was? It was like a pocketbook. So that was quite interesting, right? This is important because communication sends certain signals, and all of us actually deal with it every day. Even the baby or a child who's not driving yet realize the different signals in society. So when you see this, what is it? Traffic light. And so the question is, what signal is transmitted? And also, what action is taken? So with green, we all know what action to do, right? What do? Go. What about with yellow? What do? Speed up. What does it mean, though? Slow down and yield, but most of you sound like you're probably an aggressive driver like me where you're going to speed up. So it's really important of these different cues. And the reason I'm bringing all of this up is you have to think about within our bodies, that our cells in our body has a way of communicating, and it's a cellular communication system. And don't worry, you're not going blind. I intentionally blurred it because this is a very complicated concept to understand, cellular communication and signal and transduction. And with that, what you also need to realize that, look at all these different complexes that we have to think about. Therefore, it requires a great deal of acting correctly. And if it doesn't, you see that all these diseases could happen if the communication is lost, or is not just lost, if it's not communicated properly. And this is important because you have many molecules in our body. So look at all these molecules that are responsible for signaling transduction. What's interesting is, of these molecules, and let's say some of them are named enzymes, which should make the communication more efficiently, about 10% of them are pseudoenzymes. And what you can see, that was subtle. I don't think you really understand the importance of having 10% of the molecules in our body that are responsible for all of our cellular reaction being a pseudoenzyme, meaning that it possibly cannot do its function. So because I think you didn't get that subtle of the yellow, the 10% of the yellow turning blue, I would ask if all of the people on the front row would just take a stance. And I know this room seats 420, but it's not 420 people in here. But that's like saying to you that you're pseudo. And let's think about that term pseudo. False, bogus, irrelevant. Do you really feel like you're bogus, irrelevant, false, or fake, or quasi? No, because you're a part of this auditorium. You're a part of all of us, right? And so, please, thank you very much for your participation. Please have a seat. So, no, you're not false, irrelevant, bogus. So I wonder why scientists in my field decided to use this term pseudo to put in front of enzymes, and then it becomes problematic. What is a pseudoenzyme? It's a fake enzyme, therefore it can't do anything. I'm here to say today that no, it's not. Yes, it's a pseudoenzyme that cannot do its particular job enzymatically, but yes, it can do a great deal of things, and we need to pay more attention to it. And so I'm going to take you through the roles of what pseudoenzymes do very briefly. One role is, you see we have this molecule. It has a phosphate group on it. And you see that you have this molecule, the pseudoenzyme, binding to it, and it serves as a competitor, that it competes with the active enzyme. So that's one role it has. The other role is it's a modulator. So for the speakers, we were able to not pay, but that's not necessarily true. We didn't get any monetary monies to the organizers to walk in this room, but we are standing up here speaking, right? But the rest of you actually probably gave some type of funds. So it was modulated of how you would walk in this room. So pseudoenzymes also modulate or regulate other molecules in the cell. And then the other one is the anchor. And this is the one where the cameraman and I might not get along just for a while. But you think about positioning, that you anchor, that they anchor each other in a particular cell. So the other thing we want to think about is it serving as a signal integrator. And so with that, I'm going to need some help. So these are cues, and I'm the outsider right now. So I'm looking at all of you as my cell and your various molecules in the cell, and I want to pass you a signal. And the young man, could you raise your hand, Matt, has agreed to receive this signal. But the signal is going to come from two different places, and I'm anchored in this red place here, so I can't move. So I need someone to come give the signals. And what I would like you to do is to pass, not walk, but use the crowd to pass the signal to Matt. Please raise your hand. So you can truly understand what signal integration is, that you have a cell that receives cues, and from two different pathways, and within that, you have to have integration of a signal. And so we will politely wait on Matt to receive the signal. He has received the signal. And let's see, will it be followed properly, or do we have a mutation and it doesn't work? And see, it's complicated, right? It takes a while for the signal to be transmitted. Beast mode. So beast mode was the signal that beast came from the left, mode came for the right, but we had to integrate that signal into one. So now that I've told you the functions of pseudoenzymes, do you remember the 4 functions of a pseudoenzyme? I'm waiting. Anchor. Modulator. Signal integrator. And what was the other one? All of you William and Mary students are this anyway, competitors, right? Compete. So now I would like to turn your focus to that you actually have pseudoenzymes that have a relevance for Greek mythology. And that was really great for me because this field is only 19 years old, but my lab has been looking at this field, or I should say I have been looking into this field for 15 years of the 19 years. And I fell in love with one that was named after Greek mythology. And why do you think it was named after Greek mythology? It's simple, right? STYX. because of the STYX river. And so this is MK-STYX, the protein that my lab actually focuses on. And this part here is part of the pseudophosfatase, is within this particular domain. These letters here makes it a pseudophosphatase. Why? Because they don't have these amino acids. So if you ever see a sheet of paper with letters on it and it have these amino acids in this particular order, we know that it is actually a phosphatase. And I'll tell you what a phosphatase is in just a few seconds. Notice that MK-STYX does not have this, therefore it is a pseudophosphatase. So if it has these letters, these amino acids, it's a phosphatase, which means this molecule has a phosphate group. It has the ability to remove the phosphate group, but a pseudophosphatase, all it can do is grab and hold on. And because of that, that's why this particular molecule was named after the River of the Dead, because, oh, it's dead, it can't do its job. I just showed you 4 things that these particular enzymes can do, but now I want you to think about what MK-STYX itself can do. So let's talk about stress. It's been very stressful to have to think about how do you put together a TEDx talk, especially when you read and it says, this is the most best talk in your life. I'm like, I'm not even halfway living my life. Hopefully it's not. Do hope it's good, but it shouldn't be the best yet. But I thought about, what do I do when I'm stressed? I'm going to grab a bag of chips. They have to be sour cream and onion, and they have to be Utz, because that's how I cope with my level of stress. Think about how do you cope with your level of stress. But most importantly, how do cells cope with stress? And cells do receive the signal to cope with stress and to become stressed. So this row here, this is how cells from the kidney look. So these are cells from the human kidney. They're fine. This is the nucleus, and this is the cytosol. We see green because we use the green fluorescent protein from the jellyfish so that we actually can observe cells. But notice, what do you see when we actually make this cell stress? Does it look like the green fluorescent protein is uniform here? No, then you see clearing of the nuclear, you see these large aggregates. So this is when cells are stressed, this is what normally happens. It protects itself. The cells are protecting itself, its messenger RNA, the signal, to make sure it's receiving the right signal. But notice if we put this pseudoenzyme in here, MK-STYX, do you see these big globules? What is happening here? Is it the same size? So, no, so you know that. So now you can tell me, so what happened? Is it smaller, larger? Smaller, exactly. So this pseudophosphatase is able to decrease stress granule formation. So that's one thing to think about stress. And actually, these stress granules have a huge role in neuronal development. So that's when my lab decided to use this neuronal model. So notice these cells are quite boring. They're round cells. We got them from a rat, the adrenal medulla. So we got this from an adrenal gland in the rat, and they're just round and boring. But watch this. We put in MK-STYX. Look at that. This particular cell looks like a neuron. It has extensions that we call neurites, and it's just beautiful what it does. So are you believing that we should be paying attention, or do you agree with me that we should pay attention to pseudoenzymes now? We need to pay a lot of attention to pseudoenzymes. But I can tell you, I'm not a neuroscientist. Caroline shared with you that I'm a molecular biologist and biochemist. So neuroscientists often critique me and say, oh, those are not really neurons. What is MK-STYX really doing? It's just a fake enzyme. So here's a real neuron from a rat brain, and you see the cell body, the axon, and then you see these dendrites. Do you see that morphology with MK-STYX? Right? It changes it, but we don't know which one of these are the axons, because the axons distinguish itself by being the longest. We can't tell which one is the axon. What's also amazing, look at how these have their own space, these neurites. These neurites don't have their own space. They're beginning to fold upon each other. So it's clear that MK-STYX, the pseudoenzyme, has a tremendous function in cellular regulation. That's what my lab is still beginning to deal with, to figure out exactly how is it doing what it does. And so I want to remind you how we started this conversation. We started this conversation talking about communication. And as you can see here, this is Hampson gentleman is my dad, and he was so excited that he saw a retro phone booth in Toronto, I think it was October last year, and he went in there and picked it up to see, does it still have signal? It had signal. So we still have just a few of these phone booths, in the United States, but only a few in New York and probably Chicago. And then we have this kiosk. And so I want you to pay attention to now what, I won't call it a phone booth, but it is used to make phone calls. But look at this new technology. It was just a national show on it on CBS just a week ago today. But actually look at what this technology does. So now if you visit New York City, you're going to see many of these kiosks, and probably New York, Boston, Chicago, your major cities. And so it allows you to charge your phone, it allows you to make a phone call, allows you to figure out what direction you need to go. And for me, what I think about is, compared to the phone booth here, it is definitely much more efficient. It's less laborious, meaning you don't have to open it up, step in, pick up, dial. Well, I want you to really think about what I've been talking about, pseudoenzymes. And why is it that because pseudo is in front of it, that we don't want to give it the ominous that we should, and that we really should start paying attention. But because, of course, as societies are allowing communication to evolve, of course our cells are allowing communication to evolve, and we need to pay and be respectful to the revolution of pseudoenzymes. So I really appreciate your attention. Thank you for coming to see the TED Talk, and I hope you hang around. Thank you.